Swayam Prabha. Digital India. Educated India.
Now I will take an example circuit and calculate its Y parameters. Let me take this circuit. This is port 1, this is port 2. Very simple circuit, but for now let's use this, and let's say this is 1 kilo ohm and this is 2 kilo ohm, and we want to calculate the Y parameters, and we will do it one by one using the algorithm we described earlier. So, Y11 is I1 by V1 with V2 being shorted. Okay. So, I short the second port and I apply a voltage V1 to the first port. Now, it is clear that this V1 appears entirely across this 1 kilo ohm. Because of this short, the voltage across this 2 kilo ohm resistor is 0. Okay. So, this current I1 here is nothing but V1 divided by this resistance 1 kilo ohm. Okay. Now, what I wanted was I1 by V1. This turns out to be V1 divided by 1 kilo ohm divided by V1, which is equal to 1 by 1 kilo ohm or 1 millisiemens. Okay. So, that is what Y11 is. Now, Y21, the measurement setup is the same. I still set V2 to 0, that is short circuit the second port, but this time I measure I2 instead of I1. Okay. So, what do I get? I2, and also keep in mind the direction of I2 has to be measured that way. Now, again this V1 appears entirely across this 1 kilo ohm, and because this 2 kilo ohm resistor has a short across it, no current can flow through the 2 kilo ohm resistor, the voltage across it is 0. So, we have a current like this in this direction, which is V1 divided by 1 kilo ohm, and if you look at I2, it is the same as this current, but with the direction being opposite. So, I2 is simply minus V1 by 1 kilo ohm. Okay. So, this is minus V1 by 1 kilo ohm divided by V1, which gives you minus 1 millisiemens. Okay. So, that is the value of Y21. Now, let us consider the other parameters. We know that Y12 is I1 by V2 with V1 set to 0. I have to short circuit port 1. So, let me do that. This is 1 kilo ohm, that is 1 kilo ohm. Okay. Now, I short circuit port 1 or set V1 to 0 and apply V2. Okay. So, if I apply V2, what happens? First of all, there is a current V2 by 1 kilo ohm in that direction, and there is a current V2 by 1 kilo ohm in that direction. and the current that goes in here is the sum of the currents in the two resistors, which is V 2 by 1 kilo ohm times 2. Okay. It is basically this plus that. Now, for y 1 2, what do I need? I want I 1, which is the current this way. Okay. I already evaluated that. V 2 by 1 kilo ohm flows that way. So, I 1 is the negative of this. So, I 1 is minus V 2 by 1 kilo ohm, which gives you minus V 2 by 1 kilo ohm divided by V 2, which is equal to minus 1 millisiemens. Okay. And finally, y 2 2 is I 2 by V 2 with V 1 equal to 0, that is port 1 short circuit. Same condition under which we measured y 1 2. Okay. So, I 1, which is this current, we have already calculated that. I 1 is 2 times V 2 divided by 1 kilo ohm. So, y 2 2 is 2 V 2 by 1 kilo ohm divided by V 2, which is equal to 2 millisiemens. Okay. So, now we have this circuit 1 kilo ohm and 1 kilo ohm, 1 prime 2 prime. A representation of this is as a 2 port network. Okay, 1 prime 2 prime with the y parameters, which are 1 millisiemen, minus 1 millisiemen, minus 1 millisiemen and 2 millisiemens. Okay. So, what can be done is, instead of analyzing this circuit, you can take this 2 port and the equations corresponding to that, which is basically I 1, I 2 being y 1 1, y 1 2, y 2 1, y 2 2 times V 1, V 2 and use that instead. Now, this circuit is so simple that you can analyze anything even with this circuit in place, but you could have 100 resistors in here. As long as you have only 2 pairs of terminals provided to you, it can be represented by only 4 parameters, the 4 y parameters. Okay. So, the calculations become a lot simpler. So, this is an equivalent representation of that one. Okay. So, that is all that is there to it. And we can take another example. This time I will use a control source. Okay. Let me define this as Vx, and this is 2 millisiemens times Vx. It is a voltage controlled current source. Okay. And this is port 1, this is port 2. So, how do we go about determining the y parameters of this? Again, exactly the same algorithm as before. So, for y 1 1, you short port 2, that is, you set port 2 equal to 0 and find the ratio of I 1 to V 1. Okay. And for y 2 1, you also short port 2 and find the ratio of y 2 to V 1. So, in other words, what we do is we short circuit this, apply V 1 here, and we need to find these 2 currents. Okay. We need to find this current I 1 and this current I 2. Always please keep in mind where the currents go. This current is going into the 2 port, right, that is in this part here or in this part over there, and that is true for both I 1 and I 2. So, the directions are very important. Now, because I have shorted port 2, across this 1 kilo ohm there is 0 volts and no current flows through this one. Okay. And this V1 appears entirely across the 1 kilo ohm resistor over here. So, the current through this 1 kilo ohm resistor is V1 divided by 1 kilo ohm, and the current in this control source is nothing but 2 millisiemens times Vx, and Vx is the same as V1, okay, in this case. So, this is 2 millisiemens times V1. Okay. So, and that goes in that direction, and the current through this is 0 as I mentioned earlier. So, firstly, this I1 simply equals this V1 divided by 1 kilo ohm, or V1 times 1 millisiemens, because 1 by 1 kilo ohm is 1 millisiemen, and this I2 is nothing but the current through the control source minus the current coming in from this resistor. Okay. And that happens to be 2 millisiemens times V1, that is what going down into this, nothing is going here, minus the current V1 by 1 kilo ohm, which is minus 1 millisiemens times V1. Okay. So, substituting these values, we get I1 is 1 millisiemens times V1 divided by V1, which is 1 millisiemen, and this is this difference, which is also 1 millisiemen times V1 divided by V1, which is 1 millisiemen. Okay. Then we have to calculate the other two parameters. We have to calculate Y12, which is I1 by V2 with port 1 shorted, and Y22, which is I2 by V2 with port 1 shorted. So, for these two measurements, I have to short port 1, apply V2, okay, and I need to find the currents I2 flowing that way and I1 flowing that way. Okay. Now, I have shorted this here because this is shorted. By the way, this control source is 2 millisiemens times Vx, where this is Vx, and with port 1 shorted, Vx equals 0. Okay. So, this current source here will be 0, it is out of the picture. Now, it is clear that this V2 appears across this 1 kilo ohm as well as that 1 kilo ohm. Okay. So, we have a current V2 by 1 kilo ohm over there and a current V2 by 1 kilo ohm over there. So, if I measure I1, it is the same as the current in this resistor and it is in opposite direction to this V2 by 1 kilo ohm. So, we have minus V2 by 1 kilo ohm divided by V2, which gives me minus 1 millisiemen. Okay. And I2, which is the sum of these two currents. Okay. In fact, looking from this port, if you look at the conductance seen at port 2, you see that this 1 kilo ohm and 1 kilo ohm are in parallel. So, sum of these two currents V2 by 1 kilo ohm plus V2 by 1 kilo ohm. So, that gives me 2 times V2 by 1 kilo ohm divided by V2, which is 2 millisiemens. So, the Y parameters of this network, the Y matrix is 1 millisiemen, 1 millisiemen, minus 1 millisiemen and 2 millisiemens. Okay. So, again the point of this is you can use these equations with only 4 parameters instead of looking at all the details within the circuit. Okay.